Good morning, everybody, and apologies for the delay. If those of you who were here last year, the same thing happened, and I did a dance there and then, but this time of year, this time I probably won't do the dance unless things start going really wrong again. So, most of you would have seen, is that too loud? Coming through too loud, by the way? It sounds really loud to me. It's good, yeah? Okay. TBA was listed as my title talk. That's because I usually write it the night before, and indeed I was up to the wee hours of this morning doing the same thing. So today we're going to talk about a modern history of database insecurity and why should Infomix be any different, basically. If the slides will progress. So I recently did a security assessment of Infomix. The talk will discuss a number of the flaws that were found during that assessment, finishing up with a demonstration. But before going through all that stuff, I want to put the problems found in Infomix in context in relation to other database servers, because it would seem unfair given the end result. Sure? No, we can't. That's what one of the biggest problems was earlier on, sorry. Later on, I'll be doing a demo on that side. So, yeah. So you guys won't see that. But at least you guys get the slides, you know. So, if they put a big mirror at the back of that wall, that would be perfect. Everyone could just face that way, and I would not have to look at you guys, you know. So, in my opinion, database, yeah, if you guys want to move over quickly, or if you don't need the slides, just stay where you are, it's up to you. As far as I'm concerned, database insecurity is the biggest problem we face today in the world of IT. Just as a couple of demonstrations of this, database software is riddled with holes. We just need to look at the track record of some of the products that have been available to us. For example, Oracle, SQL Server, DB2, Sybase, all of them. We'll go into that in a bit more depth. But for some reason, they've all been secure from the get-go. It is bizarre. Oracle recently this year have fixed over 100 security flaws, and we know they have at least 400 more to fix. How do we know that? Because when we look at the flaws being found by people like myself, Alexander Cornbrush, Cesar Serrado, Chris Anley, and that lot, we see them being fixed in Oracle critical patch updates. And then Oracle tell us on top of that they find internally 75% of the issues. So one would expect that, you know, given that Alexander announced the other day how many flaws he had, and I did, and Cesar did, and between us we had 100 there to be fixed. If Oracle are finding 75% of issues internally, then that means there's 400 more to be fixed. Why is database insecurity the biggest problem as far as I'm concerned? Because in the event of a successful compromise, there is the biggest threat to the organization. The database server holds the crown jewels, of course. So there's the biggest potential for threat, biggest potential for fraud, loss of consumer confidence, and even opportunistic competitors. Now, what I mean by competitors could act on the commercial level or even the international level. You know, as in government organizations. So it doesn't get the attention it deserves today. Everyone is concerned with website defacement still to this day. And I think the reason is because within most organizations there's still a lack of understanding of the threats that database servers are exposed to. Most DBAs, especially Oracle ones, will turn around and say, oh, I'm protected by all these firewalls and we run on Unix. Like that makes, running on Unix makes your database secure. Attacks tend to be invisible. A database hacker will not deface your website. They will not go around boasting that they just hacked into foobar.com. They will, keep their access and they will steal your data, and probably silently. So they're not going to announce their presence. And what's more, because a lot of people don't understand how the attacks take place, they don't know what to look for in terms of their intrusion detection, intrusion prevention kind of systems. So a lot of these attacks are going under the radar. Vendor marketing. Well, if companies out there say their products are unbreakable, who are we to disagree with them? Except if you're a security researcher, of course. And lethargy. So many people are unwilling to install patches upon their systems because they're so frightened it's going to break the application, which is fair enough, to be honest, because let's face it, computer software is there to enable business, and security should not be an inhibitor to business. So if installing a patch means you can't do business, then don't install the patch. Find another way to mitigate the risk. So the problem is people use it as an excuse too much. They say, oh, I'm not going to install that patch because I know it will break my application, but they've not done any assessment as to whether it will actually break their product or not. So I think we need to be less lethargic and actually sit down, test these things properly, and see if we can actually roll these patches out as soon as possible. Sorry, I'm just waiting on the slides forwarding. Okay. I had a chat with Adam Shostak at Blue Hat the other day, and we spoke about how many publicized compromises have been due to something like a direct database attack or a SQL injection attack. And he came up with a really decent list for me. He maintains at emergentchaos.com a list of a catalog of breaches, basically. The URL is at the bottom of that thing, but you guys can't see that. emergentchaos.com, essentially. Now, I don't know whether he continues to maintain that, given that he now works for Microsoft, but I don't see there being any problem. You know, I don't see that Microsoft would have a problem with that. But suffice to say that there is an extensive list of publicized breaches on that site. He pointed to me in the direction of a number of them which he believed were due to SQL injection, given his insight into this, into these breaches. So, obviously, everyone heard of the card system solutions. 40 million credit cards taken from a database. Then there was the Rhode Island state government database, 53,000 credit cards and national security, not national security IDs, social security identifiers. 320,000 SSNs from the USC, University of Southern California database. That was July 2005, and so on. The list goes on. But it shows you that the database attacks are out there. It's just they're not being noticed as much. Well, I think as time goes on, they're going to be noticed more and more often. Sorry, my computer's deciding to wake up and do something fun. At the end of 2005, I conducted an assessment as to how many database servers are exposed out there. The reason I did this was because of people saying, oh, my database is tucked behind a firewall, you'll never get to it. Well, forgetting SQL injection issues, how many are actually exposed on the internet out there? So I conducted the survey looking for open database servers, i.e. not protected by a firewall. The search included Oracle MySQL and MS SQL. If we look at the results, and I can bring the results up now. Essentially, sorry, you guys won't be able to see it, but I found in approximately 1 million IP addresses, 30 exposed SQL servers, 18 Oracle servers, and get this, 847 MySQL servers. So that's staggering. Now, if we extrapolate the results of that, we can basically say across the internet there are 210,000 MySQL servers out there that are not protected by a firewall. There are 140,000 Oracle database servers not protected by a firewall, and 560,000 MySQL servers. Now, I want to normalize those results because the skew towards MySQL seems extremely unfair. So if we look at when you break them down by organization, it turns out that there are 21 organizations with their SQL Server exposed in that address range. 17 organizations had their Oracle servers exposed, and 31 MySQL servers. So that 857 MySQL servers has now come down to 31 different organizations. So I think we can expect that it's because of web farms and hosting environments, basically, that's why there are so many unprotected MySQL servers. If we look at the range of versions of Oracle, we see that the majority of them are 8.1.7.0. That's really interesting because Oracle no longer supplies patches for that version of Oracle. And what's more, they are vulnerable to an attack whereby without credentials, we could load an arbitrary library and get it to execute an arbitrary function and pass it arbitrary parameters. Now that's a vector for a 1 if ever I saw one, So we should be, concerned with protecting our database servers in a much more robust fashion. If you want to look at the operating system split, 8 of them were running on Windows, 8 Linux, and 1 each on Solaris and AIX. This has been published on www.databasesecurity.com, by the way, if you want to get a copy of it. And it goes through several breakdowns. Then we go into SQL Server. The vast majority of them there are now patched, as a consequence probably of Slammer. There are still a few unpatched ones out there as well. MySQL, the vast majority are running version 4. 319 of those systems found. 58 of them were running 3.23 as well, so quite interesting. So let's talk about the insecurity of database server software now. I personally started out with Microsoft SQL Server way back in probably about 2001. And at the same time, Chris Anley, a colleague of mine at NGS, and a guy called Cesar Serrado, and another guy called Jim, has spent a lot of time basically banging away at SQL Server. And there was about 30 flaws found at that time. And SQL Server was put through the Wrangler, and it stood out because it seemed to be that that was the only database server being picked on, and all these flaws were being found. So in that context, it was like, oh, don't install SQL Server because it's full of holes and everything like that. But that's because no one else had looked at the other products yet. So as soon as Larry Ellison says, oh, my product's unbreakable, well, that's like waving a red flag to a bull. So a lot of researchers homed in on that product. So Oracle have never looked back, really. They've been churning out patches for flaws ever since. And when Oracle say they're committed to security, they are committed to security. They're committed to releasing security patches for the next wee while. In fact, if you go to their site, we know that they're going to publish on such and such a date. Now, if we think about that, what that means is until at least July 17, 2007, which is when the very last CPU they're talking about, and I expect there's going to be another one after that. But the point is, until July the 17th, 2007, we can expect that your Oracle database servers are in a state of critical insecurity. Because if they're promising they're releasing critical patch updates, for the next 3 months coming, for the next year, then that says to me, my software is critically insecure. So I think that's a marketing own goal there. They should not be, they need to think about it differently as far as I'm concerned. DB2, I performed an assessment on that in about January 2005. Spoke to IBM about 10 floors or so. A couple of my colleagues at NGS Software in December 2003 did Sybase, literally did Sybase. They published about 50 flaws and worked with Sybase to get those fixed. That was Mark, Sharif, and Rob. So SQL Server, when it was first released, had 1 billion flaws in there. Oracle had 1 billion flaws. DB2 had 1 billion flaws. Sybase had 1 billion flaws. Excuse the hyperbole. There's a bit of a difference between 50 and 1 billion, of course. But Suffice to say that this software, when it came out, was riddled with holes. So should Infomix be any different? Should we expect anything better? And of course, there wouldn't be much of a talk if they were like ultra secure. So let's talk about Infomix. What is it? Infomix is just another relational database management system. It was acquired by IBM in 2001. In the early 1990s, it was actually the second most popular database server out there, which is quite interesting given that it's not so popular these days. Current supported versions are 10.0.xc5 and 9.4.xc8. Now, what do I mean by that X? Well, let's look at version numbers just quickly so I can explain this. So it starts with a major .min, that's the number, like 9.40 or 10.0. If you see, when you're doing an assessment, let's say on an Infomix box, an FC, then you know you're on a 64-bit platform. If you see a UC, you are running on IRIX, Linux, Solaris, or AIX. If you see TC, you're on Windows, and if you're on HC, you've got an HPUX box. If you see TL, it says you're on a time-limited trial version, and RXN, where X is a number, is a release candidate, so like a debug build. So that's how you can fingerprint what OS the Infomix server is running on. Let's talk about Infomix authentication. Uses operating system accounts, very much like DB2. You don't have database logins itself. The default user, when you install Infomix, is called Infomix, and depending upon the version, most of them will give you a default password of Infomix itself, unless you change that. On Windows XP, if we don't have an account, let's say Infomix Dynamic Server is running on a Windows XP box. If we don't have an account on that box and simple file sharing is enabled, remember this is XP I'm talking about, then if we log on with a non-valid username, i.e. a username that doesn't exist, we can gain access to the system. And the reason is because simple file sharing has been enabled. And when you pass the username to log on user, Windows logs you on as the guest user basically, and returns a token. So as far as Infomix is concerned, you must have had a user ID and password and you logged onto the system. There is a buffer overflow in the authentication process. By presenting an overly long username of 260 bytes or more, you can basically overwrite the saved return address on the stack and execute arbitrary code. We'll see that in the demonstration shortly. Now, IBM fixed that. And in fixing that, they introduced another buffer overflow vulnerability. What they do is they say, if the username is now longer than 32 characters, log an error. And in logging that error, they pass the username that was supplied to a call to vsprintf with a fixed size buffer of 960 bytes on the stack. So even their fix could be exploited to gain control. So currently, 9.40.x.c8 is still vulnerable to that, but you can go to IBM and get an interim patch before they release C9. 10.0.xc5 prevents this flaw. And the CV numbers that have been assigned are 3853 and 3854 for those two specific flaws. When you attempt to authenticate, the user ID and password is sent across the wire in clear text. So anyone who's able to sniff on the network or at least have a shell or some ability to gain, capture that traffic, then you can start picking off user IDs and passwords. You can prevent that with a communication support module. There are two of these. One is a simple password CSM and one's an encryption CSM. The first one, you obviously encrypts the password as it goes across the wire. The second one encrypts the data. Another thing about passwords, which I haven't mentioned in the slides, is the clear text passwords are stored in a shared memory segment in the process, basically. Now, if we can get the Infomix server to core dump, which we can do, as we'll see later on, then that shared memory segment is dumped into a world-readable log file. So we just grep through that for people's clear text passwords. On Windows, the shared memory segment, everybody can open the section, basically, so we can just read directly from the virtual address space of the on-init process. So there's a number of password exposure issues there. If you analyze the protocol, once you've authenticated, the second byte of the next packet becomes an index into a function table, basically, and that determines what goes on next. There's a whole range of buffer overflows. For example, the remview SQL stuff, remproc, remove permissions, and so on. The list is on that side of the room. There's no point in me reading through it because there's lots of them. Suffice to say that all of them call the getName function. The getName function basically takes a source string and copies it to a destination buffer, very much like the strcpy function in C, essentially. So wherever they call getName, you're guaranteed pretty much to have a straight stack overflow. Or even a heap overflow as well, if they're using heap. There are two unhandled null pointer exception flaws at the protocol level in the scroll and the bbind functions. So anyway, let's say, forget those protocol attacks. Once you're connected, let's say what we'll see in the demonstration is actually we'll exploit the buffer overflow vulnerability to create an operating system account on the server. Once we've got that operating system account, we can then authenticate to the Infomix server. By default, public has the connect authority. The connect authority means basically that the user has the requisite permissions to connect to the server. So because public has this authority, it means anyone with an operating system account can connect to the database services. Now, once they've done that, there is nothing to stop you from saying, create database by default. So if we create our own database, once we've connected as a low privilege user, we then become the owner of that database, and as the owner, we're the DBA, and as the DBA, we can run code as the Infomix user, and as the Infomix user can trivially gain root on a Linux environment, we become root. And on a Windows environment, Infomix is an administrator, so we get admin privileges, and from there it's trivial to get system. So we'll look at that as well. Accessing the file system. How are we doing for time? Good, yeah. Accessing the file system. We can read files from the server using straight SQL. The way we do this is create a temporary table with a clob. A clob is basically a large object. We then use the file to clob SQL function to read whatever file we want to read from the server and dump it into the temporary table we've created. And then lastly, we create we use the load to file function to dump that text from the table onto the client system. So we can read any file we want as long as the Infomix user has the privileges to read that file. We can write files to the server. One of the things we'll be doing later on is basically creating our own DLL, dumping it onto the remote server, dumping it into a table, flushing that from the table onto the disk, and then loading that library to execute arbitrary code. So again, we go through the similar functions to write files to the server. If we want to prevent access to the file system in this respect, you want to revoke the execute authority on the file to clob, load to file, and IFX file to file functions. There's an interesting SQL command called set debug file, and I mean interesting because it's a fertile ground for bugs basically. So firstly, we can create output files on the server and write text to that file. The way in which that file is created on the server is with a call to system, basically. So we can inject operating system commands into the create file, into the set debug file command. We can inject operating system commands in there, and they run as the as the Infomix user. So anyone can come along and type set debug file to inject arbitrary command and have that run as the Infomix user. Funnily enough, the set debug file is vulnerable to a buffer overflow vulnerability as well. So there are 3 different attack vectors just with that one SQL command alone. And what's more, there's not a lot you can do to prevent someone from running set debug file. We spoke about loading arbitrary libraries just briefly. what we can do is using the ifx load internal SQL function, which public has the execute permission on, we can basically say, load this arbitrary library for us. On a Windows system, that will follow a UNC path. But as it happens, we don't need to follow a UNC path because we can write a DLL to the disk anyway, remotely. So what we would do in an attack situation is put the code in the DLL main function on a Windows environment or on a Linux environment in the init function. So that way, when the library is loaded by the Infomix process, the code will automatically execute. We can protect against this by revoking execute authority from public, of course, on that ifx load internal SQL function. So before I start the demonstration, are there any questions on that stuff? Nope. Oh, yep, sure. I do. CD dev CD. So I'm going to push up these advisories tomorrow, and some of these advisories, like, well, there's A2I there, and some of them, fix, like, talk about the fixes for 8 issues and so on. I'll get you the exact number shortly. But I think it's about 20 or so bugs, different bugs. But as I said, I'll get you the exact number shortly. Okay, so if you want to see the demonstration stuff, if you want to come over this side of the room. Yep. I don't know where Infomix appears in the whole range of things, but probably less than 1%. Oracle probably has between 30 to 40%. DB2 has about 30%. SQL Server, I think, has about 15%. Sybase has about 3%. Teradata, I think, has about 3%. The NCR Teradata database has that. So, but that's excuse me, that's commercial, not necessarily MySQL, or open source stuff. Sure. Oh, wonderful. IBM are really responsive. They very communicative as well, and keep you informed all the way along. And what's more, they understand that you're just trying to help secure their product. If only people like Oracle would understand that, then we could all, stop the bitching and just get on with fixing, Okay. So, sure. No, there was probably a time long ago in a galaxy far, far away where that actually was the case. But I think these days, again, there's a younger dynamic crowd within Microsoft that aren't rooted in DoD security, if you understand what I'm saying. I think that's what the problem is. When people begin to realize that security is not about DoD standards, and it's actually about more modern stuff, then people begin to realize that it's just bugs, let's fix it. A lot of Microsoft actually treat a bug these days as a company resource as well, something that is of value to the company because they can learn from it, rather than denying their issues. As I said, they treat it as a good company resource. Okay, so. What kind of traction are you getting on Informix? Sorry? What kind of traction are you getting on Informix? Very good. The guy I communicate with is a guy called Jonathan Leffler. As I said, he's been extremely responsive. And I mean, I've recently published some flaws in AIX. Shiva Persaud, on the IBM side, he again, really responsive. There was no confrontation. Then there was Scott Logan on the DB2 side from IBM. Again, really, really good. They've got a really good culture there as far as I'm concerned. Okay, so this here is the exploit code. Doesn't do much. I coded it very simply last night. It's coded for this system. because it's using hard code. You can't see it. Oh, sorry, over there. No, you don't need to move. Suffice to say that all's the exploit code. Oh, that's still not either. Right. Is it gone? Is it still there? Sorry. Tell me when it's back. Sorry. Is it that? Right. Woo! Okay. What the exploit code does basically is takes a string. Is it? Sorry? Yeah, I know. Forget that. Right. We don't need to see too much on here. So I'll bring up command windows, so because that's what we're going to be looking at essentially. So I'll just keep everything slightly to the right so you can see what needs to be seen. Was that what you were saying, yeah? That half of it's being chopped off? Oh, no, you don't need to see that anymore. Basically, I'm going to be running the commands from there. Sorry. So, yeah, this is the Infomix server. So I want to, show you what's going on. So, net user. Let me delete net user itest because that /del net user. Okay, so basically what the code I'm going to fire off to exploit the buffer overflow vulnerability in the authentication procedure is I take a string, XOR it with oxcc to get my command out, which is just going to be net user I space /add, and pass that as a parameter to the system function. And Bob's your uncle, that should go ahead and create the, let me just ping the thing, see if we've got the connectivity I require. 168.1.101. No. (102). Sorry, just give us a sec. Has been visualizing into Pro. No, cancel. Sorry, nearly there. Looking good? Right, we're in business. So, as I said, all I'm going to do is basically exploit that buffer overflow vulnerability on the Infomix server to create a user called I, basically. So ifx2 192.168.1.101. Do I need the port? Yes. 1526. So this is basically connecting, sending the exploit, create user I with password I. User I should now exist, you may log in. Let me just do a net user. So there we can see the user I has been created. So now we've got access to this system. The exploit is pretty turdy because I don't clean up after myself and the server crashes. A real exploit, of course, would make sure we recover gracefully and can go ahead and log in. So I've just restarted the server. The next job, basically, is to show you if I connect and do a create database. But where are we? Again, it's unfortunate the screens are so far apart and not angled, because it would be much nicer to be able to see everything, what I'm doing on the client side to attack versus that. So I'm actually running the DB access utility, which is an Infomix supplied util basically to connect to the database. OL Apollo is the one in question. The username is I, password is I. It's then waiting to connect. Now connected, select the sysmaster database, and that's me done. I can then issue a query, so I would do create database black cat. And then run that query, and it says database created. Again, you guys can't see that over there. But if I now use that as a database, exit from there, select the database. We have black cat, for those that can see it on this side, black cat as a database. And now if we do a select star from sysusers, escape and run, we can see username I is a user type D, which says we're a DBA, essentially. And I know you guys can't see it over there, but what's just about to happen shortly over here is much more interesting. What I'm going to do is create a library on my system here, a DLL, then I'm going to upload it onto that server over there and dump it from the disk and so on. So the code basically is going into DLL main, notepad, what am I calling it? Loadme.c. So there's the code for, I wish I could turn that thing. Hey guys, there's the code. And I compile that cl/ld loadme.c. Then using I'm going to use a tool called Advanced Query Tool, a very good tool by the way, to connect to the remote server, which is I sign on.
Can I reproduce what you're doing on a Unix box though?
Yeah, you can absolutely do this, yeah.
So it format has to run as root on a Unix box?
No, it doesn't have to run as root, but it runs as the Infomix user. But so many of the binaries are set UID root that it's trivial to gain root from Infomix. There's, on Infomix running on Linux, there is the SQLi debug environment variable, which basically, when a shared object reads that environment variable, it causes stack-based buffer overflow. And because every binary loads that library, including the set UID root ones, we can trivially gain root privileges that way. Basically, like on mode, for example, is set UID root. And we just run that, and Bob's your uncle, your root. So this is me now connected over here. What I'm doing is going to create the table, a temporary table called DLL table. Now, if I put farm running in the background here, on the on-init process, did that execute? Okay, number of rows affected, good. So I'm loading the DLL from my system using the file to club function to transfer over the network the DLL into this table. So I hit fire, that goes off to the Infomix server. I can then dump that to the disk. So if I fire that now, you should see it creates a file called loadmeout.dll and then a hexadecimal number. So, see, I know let me see if I can increase the font size. No, it doesn't look like so. But suffice to say that is what you're seeing there in Farmon is the loadme.dll being written to the disk. Now the thing is, if we now want to load this into the address space of Infomix, there is another step we have to go to, because unless the file attributes are read-only, Infomix will refuse to load the library. Remember, we're going to use the ifx load internal function to load it. If the attributes aren't read-only, then the server will refuse to do it. So I'm going to inject into the set debug file command. I'm going to run the attrib command to set the read-only attribute on that DLL. So we can then go ahead and load it into the address space. So if I play that, let's have a look. Dir load me DLL attrib load. So the read-only attribute has now been set on there. Now that's been done, we can go ahead and replace the module, which will then load it into the address space of the on-init process, execute the code within DLL main, which basically does net user itest add net local group administrators itest /add. So we create an administrative account and fire that off. Sorry, I forgot to cut and paste the name of the DLL it creates, so let me just do that one more time. Control V. Load me out to, let's call it, play. Okay, edit, copy. I then need to run the attrib thing again. So that should dir load me to attrib. If we look at the file attributes for that, that should now have the load me to. Oh, it doesn't have the. Sorry? I can't hear you. Oh, thank you. Play. File attributes are now set to read only, so now we can go ahead and load that using the replace module function. Control C. And now, if we do a net user, itest, whoops, net user on here, there is our itest account that we just created, and if we look at that, we see it's a local administrator. And do I have list DLLs in here? No, I don't. Let me see if I can copy across. You can backslash Windows dir list copy net use. Sorry? What, Infomix? Well, if Infomix is your, RDBMS of choice and you need to run it in a network environment kind of thing, then it all depends on, where you want to use it. But yeah, you could run it as a standalone machine. But why not do that to SQL Server or Oracle, or copy list DLLs to zcon /cd tools list DLLs on init.exe should show that our loadme.dll is now in the address space there. And that is just in time, finished just in time, I think, for the end of the talk. So that's it. That's the end of the demonstration. Thanks very much for coming. I hope that was of use. I'll give all this information to the Black Hat people so they can put it, the slides and everything like that up on the Black Hat website and make it available to you. Okay? Thanks very much, everybody. Yep.